Before you design a cloud solution on Google Cloud, there is one costly mistake you need to avoid: choosing the technology first and only thinking about the business requirements later. That approach can lead to poor architecture, unnecessary costs, scalability problems, and even exam mistakes. In this complete 6-section study guide, we'll build your understanding from the ground up, starting with the core principles of Google Cloud architecture and learning how to turn business requirements into the right technical decisions. Watch the complete video because each section builds on the previous one, and in the description, you'll also find a free study guide with the most important questions and topics to help you prepare. Stay until the end, because I'll share practical tips on how you can prepare smarter and make it much easier to pass the Google Cloud Professional Cloud Architect Certification exam. A Google Cloud Architect acts as a bridge between business goals and technical solutions. On the exam, you will frequently be tested on your ability to look at business requirements, such as cost efficiency or compliance, and translate them into specific cloud services. Understanding why a business chooses a particular cloud model helps you select the right architecture from day one. Google Cloud organizes all resources into a clear hierarchy that controls access and billing. At the top sits the organization node, followed by folders, projects, and individual resources. Projects act as the primary boundary for enabled APIs, permissions, and billing. Remembering this hierarchy is essential for exam questions focusing on centralized management and policy inheritance. Identity and access management, commonly known as IAM, determines who can do what on which Google Cloud resources. In IAM, a principal can be a user, group, or service account that is granted specific roles. Each role contains a collection of permissions, allowing you to grant access safely without giving away administrative privileges. To maintain strong security, you should always follow the principle of least privilege by assigning users only the permissions they need to perform their jobs. Exam questions often try to trick you by offering predefined primitive roles like owner, editor, or viewer. Instead, you should choose curated predefined roles or custom roles to ensure permissions are strictly limited. Compute and storage resources in Google Cloud are deployed across globally distributed regions and zones. A region is a specific geographical area containing multiple isolated locations called zones. Placing your resources across multiple zones within a region protects your application against local hardware failures, ensuring high availability. Compute Engine allows you to run virtual machines on Google infrastructure with custom or predefined hardware configurations. When choosing virtual machines, you can select general-purpose machines for web servers or memory-optimized machines for large databases. Understanding machine family types allows you to balance performance against costs on the exam. Spot virtual machines, formerly known as preemptible instances, offer massive cost savings for fault-tolerant workloads. Google can reclaim these instances at any time if capacity is needed elsewhere. Use spot instances for batch processing, rendering, or continuous testing jobs where an unexpected interruption will not cause data loss. Cloud storage provides highly durable object storage for unstructured data such as images, videos, and backups. It offers 4 storage classes, which are standard, nearline, coldline, and archive, based on how frequently you access the data. A common exam topic involves selecting the correct storage class to minimize cost while meeting access latency requirements. Google Cloud offers multiple database engines depending on your data structure and scale needs. Cloud SQL is ideal for traditional relational databases like MySQL or PostgreSQL requiring standard ACID transactions. For global, highly scalable relational data requiring enterprise consistency, Cloud Spanner is the dedicated choice on the exam. When handling unstructured or semi-structured data, Google Cloud provides specialized NoSQL database services. Firestore offers flexible document storage with real-time syncing for mobile and web applications. For high-throughput analytics and wide column storage, Bigtable is designed to handle massive volumes of time series or key-value data with single-digit millisecond latency. A virtual private cloud, or VPC, provides global networking functionality to connect your compute resources securely. Unlike traditional networks, a Google Cloud VPC is global, while its individual subnets are regional. This unique architecture simplifies global networking by allowing virtual machines in different regions to communicate securely on private IP addresses. Controlling traffic entering and leaving your network is handled by VPC firewall rules. These rules are defined at the network level and can be applied to specific instances using network tags or service accounts. Exam scenarios often ask how to isolate application tiers, so using target tags to restrict access between front-end and back-end servers is a vital strategy. Google Cloud Load Balancing distributes incoming network traffic across multiple instances to keep applications responsive and reliable. You can choose external load balances for internet-facing traffic or internal load balances for private microservices. Selecting between global HTTP load balancers and regional network load balancers depends on traffic protocol and geographical distribution. Connecting on-premises infrastructure to Google Cloud requires choosing between dedicated interconnect, partner interconnect, and Cloud VPN. Cloud VPN offers an encrypted, cost-effective tunnel over the public internet for lower bandwidth needs. For high-speed, enterprise-grade private connectivity without using the public internet, dedicated interconnect is the recommended exam solution. Google Kubernetes Engine, or GKE, provides a managed environment for deploying and scaling containerized applications. Containerization packages an application with all its dependencies, ensuring consistent behavior across development and production. GKE automates cluster management, repair, and scaling, making it a primary choice for modern microservice architectures. Serverless platforms allow developers to run code without managing underlying servers or virtual machines. Cloud Functions responds to event-driven triggers like database changes or file uploads, while Cloud Run allows you to deploy stateless containers on a fully managed platform. Both services scale down to zero when idle, saving costs on unpredictable workloads. BigQuery is a fully managed, serverless data warehouse designed for fast analysis of massive datasets using standard SQL. It separates compute from storage, allowing you to run complex queries on petabytes of data in seconds. Understanding BigQuery partitioning and clustering is essential for answering performance optimization questions on the exam. Designing successful cloud solutions requires balancing key architectural trade-offs, such as performance, cost, and reliability. Every choice you make, from storage class selection to compute instance types, involves trade-offs that impact the overall system. On the exam, carefully evaluate whether the scenario prioritizes minimal downtime, lowest price, or operational simplicity before picking an answer. Congratulations on completing this foundational section on cloud architecture fundamentals. To solidify your understanding and test your readiness, please complete the practice test attached directly to this lesson. Taking practice tests actively improves your retention, highlights knowledge gaps, and boosts your exam readiness. Get hands-on with those practice questions included with this lesson, and when you are ready, move on to the next section where we will explore managing and provisioning solution infrastructure. Welcome to the second section of our course where we focus on managing and provisioning solution infrastructure. In this lesson, you will learn how to automate deployments, configure environments, and use infrastructure as code to make your cloud systems reliable and repeatable. This topic is incredibly important because modern cloud environments require fast and error-free deployments rather than slow manual configuration. Get ready to explore the powerful tools and techniques that will transform you into a highly efficient cloud architect. Infrastructure as code is a fundamental concept where you manage and provision cloud resources through machine-readable definition files instead of interactive configuration tools. By writing code to define your infrastructure, you can version control your environments just like software code. The exam will frequently test your understanding of how this approach eliminates human error during manual setups and guarantees consistent environments across development and production. Google Cloud offers native deployment tools, but HashiCorp Terraform is the industry standard and heavily featured on the certification exam. Terraform uses declarative configuration files to define the desired state of your infrastructure. This means you simply state what resources you want, such as a virtual machine and a storage bucket, and Terraform automatically figures out the exact steps required to create or update them in the correct order. A critical concept in Terraform is the state file, which keeps track of the resources Terraform has already created. In an enterprise environment with multiple developers, storing this state file locally on one laptop is dangerous and can lead to version conflicts. For the exam, you should remember to always use a remote backend, such as a Google Cloud Storage bucket, to store your state file securely and enable state locking for safe team collaboration. Continuous integration and continuous deployment form the backbone of modern software delivery pipelines. Continuous integration involves automatically testing and building code every time a developer commits a change to a central repository. Continuous deployment then automatically pushes those tested changes into your production environment, ensuring that new features and bug fixes reach your users rapidly and safely without manual intervention. Google Cloud Build is a serverless continuous integration and continuous deployment platform that executes your builds on Google infrastructure. Cloud Build can import source code from various repositories, execute a series of build steps defined in a configuration file, and produce deployable artifacts such as Docker containers. On the exam, you will often choose Cloud Build when a scenario demands a fully managed and scalable solution for automating deployments without the burden of managing build servers. Once your code is built into a deployable artifact like a container image, it needs a secure place to be stored. Artifact Registry is the modern evolution of Container Registry and serves as a single central place for your organization to manage container images and language packages. The exam often highlights Artifact Registry for its tight integration with identity and access management and its automated ability to scan stored images for security vulnerabilities. If an organization wants to host private Git repositories securely within Google Cloud, they utilize Cloud Source repositories. This service integrates seamlessly with Cloud Build and other Google Cloud services to provide a highly available environment for collaborative code development. Exam questions might feature this service when strict access control, centralized logging, and secure auditing of source code are primary business requirements for a financial or healthcare company. When managing compute resources, managed instance groups allow you to operate applications on multiple identical virtual machines simultaneously. These groups are essential because they provide automatic scaling based on metrics like CPU utilization or incoming network traffic. If a virtual machine crashes or becomes unhealthy, the managed instance group automatically recreates it, which is a key strategy for maintaining high availability on the exam. To speed up the provisioning of virtual machines, you should utilize custom images. A custom image captures the exact state of a boot disk, including the operating system, installed software, and baseline configurations. Instead of running lengthy installation scripts every time a new instance boots up, deploying from a custom image ensures instances are ready to serve traffic almost immediately, which is crucial for handling rapid spikes in user traffic. While custom images are great for baking in stable software, startup scripts are perfect for dynamic configurations that change exactly at boot time. A startup script is a file that performs automated tasks during the boot process of a virtual machine, such as downloading the latest application updates or fetching runtime credentials. The exam often tests your ability to choose between custom images for speed and startup scripts for flexibility. Hard-coding passwords, API keys, or database credentials directly into your source code or startup scripts is a massive security risk. Secret Manager is a highly secure and convenient storage system designed specifically for API keys, passwords, certificates, and other sensitive data. For exam scenarios involving secure credential delivery, your best answer will always involve storing the sensitive data in Secret Manager and granting specific service accounts permission to read it. Provisioning infrastructure also involves managing container clusters using Google Kubernetes Engine. When you create a Kubernetes cluster, you must choose between standard and autopilot modes. Autopilot manages the entire underlying infrastructure for you, including compute nodes and scaling capacity, allowing your team to focus purely on deploying your application code. The exam frequently asks you to recommend autopilot when a company wants to drastically reduce operational overhead. To help organizations establish a secure and compliant baseline quickly, Google offers the Cloud Foundation Toolkit. This powerful toolkit provides a set of enterprise-ready and open-source Terraform templates that follow Google Cloud best practices. If an exam question asks how to quickly provision a new landing zone with proper networking, logging, and security guardrails already in place, the Cloud Foundation Toolkit is the correct architectural choice. As you provision cloud resources, you must be constantly aware of quotas, which are limits Google places on resource consumption to prevent unexpected billing spikes and ensure fairness among all cloud customers. There are rate quotas which limit API requests over time, and allocation quotas which limit the total number of resources like virtual machines you can launch. You should proactively monitor these quotas and request increases well before a major product launch or database migration. Managing infrastructure effectively also means managing costs, which is accomplished through cloud billing accounts linked to your Google Cloud projects. You can set up billing alerts and budgets to notify administrators immediately when spending exceeds a certain threshold. Exam scenarios heavily test your knowledge of how to prevent cost overruns, and setting up a billing budget with email notifications or automated shutdown actions via pub/sub is the standard architectural solution. To track cloud spending and organize resources effectively across multiple departments, you must utilize labels and network tags appropriately. Labels are simple key-value pairs applied to resources like virtual machines or storage buckets purely for billing allocation and inventory management. Network tags, however, are used exclusively to apply firewall rules and network routes. Mixing up labels for billing and tags for networking is a very common trap designed to catch you off guard on the certification exam. Cloud infrastructure is rarely static, and as a cloud architect you must plan for safe application evolution. Blue-green deployments and canary releases are advanced deployment strategies that reduce the risk of introducing new software versions to the public. In a canary release, you route a small percentage of user traffic to the new version to monitor for errors before rolling it out globally, ensuring smooth and safe infrastructure updates without noticeable downtime. While both Google Cloud Deployment Manager and HashiCorp Terraform achieve similar goals, understanding their differences is vital for passing the exam. Deployment Manager uses YAML or Python and is deeply integrated into Google Cloud, but it only works within the Google ecosystem. Terraform is cloud agnostic, meaning you can use it to provision resources across multiple public clouds simultaneously, making it the preferred and necessary choice for any hybrid or multi-cloud exam scenario. Congratulations on completing this section on managing and provisioning solution infrastructure. To ensure these deployment concepts stay fresh in your mind, please complete the attached practice test right now. Practice questions will actively help you retain this knowledge and recognize the specific patterns used in real exam scenarios. Remember that the practice test is included directly with this lesson, so take advantage of it to reinforce your active learning. Stay positive, keep practicing, and I will see you in the next section where we design for security and compliance. Welcome to the third section of our course, where we explore designing for security and compliance. In this lesson, you will learn how to protect sensitive data, defend against network threats, and architect solutions that meet strict regulatory standards. Security is the most critical aspect of any cloud architecture, and mastering these concepts is vital for passing the exam and protecting real-world businesses. Get ready to discover the powerful tools that will help you create a truly secure cloud environment, and prepare yourself for an exciting dive into modern cybersecurity. When you move to the cloud, security becomes a partnership dictated by the shared responsibility model. Google guarantees the security of the underlying physical infrastructure, such as data centers, physical servers, and hardware networks. However, you are responsible for securing the applications, data, and access policies you deploy on top of that infrastructure. The exam often tests your ability to recognize which security tasks belong to you and which belong to Google depending on the cloud service model you choose. A core philosophy in cloud architecture is defense in depth, which means applying multiple layers of security controls throughout your system. If an attacker breaches one layer, such as an external firewall, they will immediately face another barrier, like strict identity verification or deeply encrypted data. Designing with overlapping security layers ensures that a single vulnerability never compromises your entire architecture. To manage human users securely, you will use Cloud Identity, which is an identity as a service solution. Cloud Identity allows you to centrally manage users, groups, and device security policies without needing a full Google Workspace email subscription. On the exam, You should recommend Cloud Identity when a company wants to migrate to Google Cloud, but needs to synchronize credentials with an existing on-premises directory like Microsoft Active Directory. We previously discussed identity and access management, but for advanced security, you should implement context-aware access. This feature allows you to restrict access to cloud resources based on a user's context, such as their IP address, device security status, or geographic location. If an exam scenario asks how to block employees from accessing sensitive financial data while using public coffee shop Wi-Fi, context-aware access is the correct solution. When applications need to interact with Google Cloud services, they use service accounts instead of human user credentials. A common mistake is downloading service account keys, which can be easily leaked in source code or stolen by bad actors. Instead, you should always attach the service account directly to the compute resource, allowing the virtual machine or serverless function to authenticate automatically and securely without managing physical key files. To enforce overarching security rules across your entire cloud environment, you will use organization policies. While identity and access management controls who can do something, organization policies control what can be done by anyone, regardless of their individual permissions. For example, if a compliance law dictates that your data must remain in Europe, you can use an organization policy to completely block anyone from creating resources in North America. Securing cloud storage is a frequent exam topic, specifically regarding how access permissions are applied to data. You should strongly prefer uniform bucket-level access, which uses standard IAM policies to control access uniformly across all objects in a storage bucket. This prevents individual developers from accidentally making specific files public using older, harder-to-manage access control lists. Protecting data stored on physical disks or in databases is called encryption at rest, and Google Cloud seamlessly encrypts all customer data at rest by default. However, many enterprise clients require more control over their encryption keys for strict compliance reasons. You must know the difference between standard Google-managed keys, customer-managed encryption keys, and customer-supplied encryption keys. For customer-managed encryption keys, you will utilize the Cloud Key Management Service, or Cloud KMS. This centralized service allows you to generate, rotate, and manage cryptographic keys while still using Google's scalable infrastructure for the actual encryption process. When an exam question involves regulatory requirements for rotating encryption keys annually while keeping operational overhead low, Cloud KMS is the exact tool you need. Data moving between your users and your applications must be protected using encryption in transit. Google automatically encrypts all traffic traveling inside its internal network between regions and zones. For traffic traveling over the public internet, you should always secure your external load balances using managed SSL certificates to ensure all communications are protected by HTTPS. Defending your applications from malicious internet traffic is handled by Google Cloud Armor. Cloud Armor is an enterprise-grade web application firewall that provides built-in protection against distributed denial of service, or DDoS, attacks. It allows you to create custom rules to block traffic from specific geographic countries or filter out common web exploits like SQL injection before they ever reach your servers. Identity-Aware Proxy, or IAP, is a revolutionary service that lets employees access internal web applications and virtual machines without a traditional, clunky VPN. IAP verifies a user's identity and device context centrally before granting access, effectively creating a modern zero-trust security model. If an exam scenario asks for the most secure and frictionless way to let remote workers access an internal corporate dashboard, Identity-Aware Proxy is the answer. Organizations often handle highly sensitive information like credit card numbers, social security numbers, or private medical records. The Cloud Data Loss Prevention, or DLP, API is a fully managed service designed to discover, classify, and mask this personally identifiable information automatically. You should recommend the DLP API when a company needs to sanitize and redact production databases before safely sharing them with a data analytics team. To gain a comprehensive view of your overall security posture, Google provides the Security Command Center. This centralized dashboard automatically scans your entire cloud environment to find misconfigurations, public storage buckets, and active network threats. On the exam, Security Command Center is the correct choice for a security team that needs a single pane of glass to monitor vulnerabilities across hundreds of different cloud projects. Tracking who did what, where, and when is essential for compliance audits, and this tracking is handled seamlessly by cloud audit logs. There are different types of logs, but admin activity logs, which record actions that modify configuration or metadata, are always turned on by default and cannot be disabled. If regulatory auditors demand proof of who deleted a production database last year, you will find that exact answer inside cloud audit logs. A major security threat for enterprises is data exfiltration, where an authorized user accidentally or maliciously moves data outside your company. VPC service controls solve this exact problem by creating a secure network perimeter around your Google Cloud services like Cloud Storage or BigQuery. This prevents data from being copied to unauthorized external projects, making it a critical exam concept for highly regulated industries like banking. Meeting regulatory compliance regimes like HIPAA for healthcare or PCI DSS for payment cards requires strict architectural choices. Google Cloud provides detailed third-party audit reports through the Compliance Reports Manager, proving that the underlying infrastructure meets these global standards. Remember that while Google is compliant, you must still configure your specific applications correctly to achieve full end-to-end compliance for your business. Security is a continuous process that requires constant vigilance and clever automation. You should strive to automate security responses, such as using cloud functions to instantly remove public access from a storage bucket the moment an alert is triggered. Proactive architecture, where security is baked into automated deployment pipelines rather than bolted on as an afterthought, is the ultimate goal of a successful cloud architect. Congratulations on completing this critical section on designing for security and compliance. I strongly encourage you to complete the attached practice test right away. Practicing with realistic questions drastically improves your knowledge retention and builds the exact skills needed for exam readiness. Please remember that the practice test is included directly with this lesson. Engage in this active learning step now, and when you are ready, we will smoothly transition to the next section where we will tackle analyzing and optimizing cloud operations. Finish those questions, and keep up the fantastic work. Welcome to the fourth section of our course, where we focus deeply on analyzing and optimizing cloud operations. In this lesson, you will learn how to monitor the health of your systems, troubleshoot complex errors, and significantly reduce your monthly cloud bill. Understanding these operational tools is incredibly important because launching an application is only the first step, and maintaining its long-term success requires constant visibility. Get ready to master the exact strategies professionals use to keep massive cloud environments running smoothly and efficiently. The Google Cloud Operations Suite provides a centralized set of tools for monitoring, logging, and performance diagnostics. Instead of logging into individual servers manually to see what went wrong, this suite aggregates data from all your cloud resources into one unified dashboard. The certification exam frequently tests your ability to choose the right tool within this suite to diagnose complex issues across distributed architectures. Cloud monitoring forms the foundation of operational visibility by allowing you to collect metrics, events, and metadata from your infrastructure. You can create custom dashboards to visualize CPU utilization, memory usage, or incoming network traffic in real time. For the exam, it is vital to remember that cloud monitoring can also monitor resources running on premises or in other public clouds, making it a perfect choice for hybrid environments. Relying solely on dashboards is not a practical way to manage cloud infrastructure, which is why alerting policies are completely necessary. You can easily configure cloud monitoring to send an automated alert via email or text message whenever a specific metric crosses a dangerous threshold. A common exam scenario involves setting up these alerts to notify the operations team immediately if database CPU usage stays above 90% for more than 5 minutes. Cloud logging is a fully managed service that allows you to store, search, and analyze enormous volumes of log data generated by your applications. Every time an API is called or a firewall rule blocks a network connection, a log entry is instantly created. Understanding how to query these logs quickly to find the exact moment an error occurred is a critical troubleshooting skill heavily tested on the exam. Storing massive amounts of logs indefinitely in cloud logging can become very expensive, making log routing an essential architectural pattern. You can create log syncs to automatically export specific logs to cheaper storage destinations based on your business needs. You should route logs to cloud storage for cheap long-term compliance retention, or route them directly to BigQuery if your security team needs to perform complex analysis on traffic patterns. When dealing with modern microservices, a single user request might travel through dozens of different containers and databases before completing. CloudTrace is a distributed tracing system specifically designed to help you find exactly where performance bottlenecks are hiding in that journey. If an exam question asks how to determine which specific microservice is causing a slow checkout process on an e-commerce website, CloudTrace is your correct answer. While CloudTrace tracks the time a request takes across different services, Cloud Profiler analyzes the actual code running inside your application. Cloud Profiler continuously gathers CPU and memory usage data from your production code without slowing the application down. You should choose Cloud Profiler when your developers need to identify inefficient functions or memory leaks hidden deep within their application logic. Error reporting is a fantastic tool that automatically aggregates and groups similar application crashes together in real time. Instead of digging through thousands of identical log lines manually, error reporting gives you a clean dashboard showing the most frequent and severe errors. It even points directly to the exact line of code that caused the crash, making it the perfect exam solution for teams wanting to quickly prioritize software bug fixes. A major part of optimizing cloud operations involves site reliability engineering, which introduces specific terminology you must know for the exam. A service level indicator, or SLI, is a carefully chosen quantitative measure of some aspect of the level of service being provided. Simply put, an SLI is the actual metric you are measuring, such as the exact percentage of successful requests your website served in the last hour. A service level objective, or SLO, builds upon the SLI to create a specific target goal for your engineering team to hit. If your SLI is the measurement of successful requests, your SLO might be a target of 99.9% successful requests over a rolling 30-day period. The exam will test your understanding that SLOs are internal goals used by the team to balance new feature releases with overall system stability. A service level agreement, or SLA, is the legal and financial contract you make with your customers regarding system reliability. If you fail to meet the strict uptime percentage defined in the SLA, your business typically has to pay financial penalties or provide billing credits to the end customer. You must remember that an internal SLO should always be stricter than your external SLA to provide a safety buffer before your company starts losing money. The concept of an error budget represents the acceptable amount of unreliability your system is allowed to have before missing its service level objective. If you still have an error budget remaining for the month, developers are actively encouraged to push new features and take risks. If the error budget is depleted, the exam expects you to halt all new feature deployments and focus entirely on fixing system stability until that budget recovers. Optimizing operations also means deeply optimizing your monthly billing costs and eliminating wasteful spending. The most effective way to analyze complex spending patterns is to enable the export of your cloud billing data directly into BigQuery. On the exam, anytime a scenario mentions a finance department needing to create custom cost reports or visualize spending trends using Looker Studio, BigQuery billing export is the mandatory first step. To significantly reduce compute costs for predictable and long-term workloads, you should proactively purchase committed use discounts. By committing to pay for a specific amount of CPU and memory for either 1 or 3 years, you receive a massive discount compared to standard on-demand pricing. The exam often features scenarios where an application has a stable baseline of users, making a 1-year or 3-year commitment the most logical financial choice. If your business cannot commit to a long-term contract, Google automatically rewards you with sustained use discounts. These automatic discounts are applied to virtual machines that simply run for a significant portion of the billing month. You do not need to sign any contracts to receive this benefit, which is a key distinction you must absolutely remember when comparing cost optimization strategies on the certification exam. Wasting money on virtual machines that are far larger than necessary is a common operational problem in the cloud. Google Cloud provides automatic right-sizing recommendations by continuously analyzing the historical CPU and memory usage of your running instances. If the system notices a large server is barely being utilized, it will proactively recommend downsizing the machine type to save money, which is a feature you should actively look for in exam questions. Optimizing performance often requires delivering content to your global users faster by utilizing Cloud CDN, which stands for Content Delivery Network. Cloud CDN caches static website content, like images and video files, at the edge of Google's global network so it sits physically closer to your users. When an exam question asks how to reduce latency for a global user base while simultaneously reducing the load on your back-end servers, Cloud CDN is the perfect architectural choice. Capacity planning ensures you never run out of critical resources during unexpected traffic spikes or major product launches. Since Google enforces quotas on the total number of resources you can deploy, you must monitor your quota usage proactively to avoid outages. The correct exam strategy is to use cloud monitoring to track your current quota limits and set automated alerts to notify administrators well before you actually hit a hard limit. Congratulations on completing this highly practical section on analyzing and optimizing cloud operations. To verify your true understanding of these crucial concepts, please complete the practice test attached directly to this lesson. Answering practice questions greatly improves your long-term retention and heavily prepares your mind for the tricky wording of the actual exam. Remember that the practice test is conveniently included right here with this lesson. Dive into that active learning now, and when you are completely ready, we will transition smoothly to the next section focusing on reliability and high availability. Welcome to the fifth section of our course, where we explore designing for reliability and high availability. In this lesson, you will learn how to build resilient systems that stay online even when unexpected hardware failures occur. This topic is incredibly important because modern businesses lose thousands of dollars for every minute their applications are down. Get ready to discover the powerful architectural patterns that keep global systems running smoothly, and prepare yourself for some of the most highly tested concepts on the certification exam. High availability means your application remains accessible to users even if individual components fail. To achieve this, you must eliminate single points of failure by duplicating critical resources across different physical locations. On the exam, you will constantly be asked to design architectures that automatically recover from disruptions without requiring a human administrator to wake up in the middle of the night. The most fundamental tool for high availability in Google Cloud is the Managed Instance Group. As we discussed earlier, these groups allow you to run identical virtual machines, but their real power lies in auto-healing. If an application freezes or crashes on a specific server, the Managed Instance Group automatically detects the unresponsiveness and completely recreates that instance without any manual intervention. To determine if an application is actually healthy, you must configure a health check. A health check constantly sends automated requests to your instances, like pinging a specific web page to see if it loads successfully. If the health check fails a certain number of times, it triggers the auto-healing process, which is a core concept you must apply to any compute scenario on the exam. Autoscaling works hand in hand with managed instance groups to handle unpredictable traffic spikes. When a sudden surge of users visits your website, autoscaling automatically adds more virtual machines to share the workload. Once the traffic dies down, it safely removes those extra machines, ensuring your application remains highly responsive while keeping your computing costs strictly under control. Distributing that user traffic evenly across all your healthy instances is the job of cloud load balancing. A global load balancer acts as a single point of entry for your users, routing them to the closest geographical region with available capacity. If an entire region goes offline due to a natural disaster, the global load balancer instantly redirects all new traffic to a healthy backup region seamlessly. When designing a database architecture, high availability requires careful planning. Cloud SQL offers a highly available configuration that automatically synchronizes your primary database with a standby replica located in a completely different zone. If the zone hosting your primary database experiences a massive power outage, Cloud SQL automatically promotes the standby replica to become the new primary database within seconds. For read-heavy applications like e-commerce catalogs, you should implement read replicas. A read replica is a live copy of your database that can answer customer queries, reducing the strain on your primary database. Exam questions often ask how to improve database performance for a global audience, and adding read replicas across multiple regions is usually the correct architectural choice. Cloud Spanner takes high availability to the absolute extreme for relational databases. It distributes your data across multiple zones and regions automatically, providing an incredible 5 nines of availability, which means less than 5 minutes of allowed downtime per year. If an exam scenario demands a globally scalable relational database with zero data loss during regional failures, Cloud Spanner is your only correct answer. When storing files and backups, cloud storage offers multi-region buckets for maximum reliability. When you choose a multi-region storage class, Google automatically replicates your data across widely separated geographic areas. This ensures that even if a catastrophic event destroys an entire data center, your critical business files remain perfectly safe and instantly accessible. Disaster recovery is a step beyond simple high availability, focusing on how a business survives massive catastrophic failures. Your disaster recovery plan is governed by 2 key metrics called the recovery time objective and the recovery point objective. The exam will aggressively test your ability to match these 2 metrics with the appropriate backup and recovery tools. The recovery time objective, or RTO, is the maximum acceptable amount of time your application can be offline during a disaster. If a business states they have an RTO of 4 hours, your recovery plan must guarantee the system is completely restored and running within that time frame. A shorter RTO always requires a more expensive and complex architecture, like maintaining a fully running standby environment. The recovery point objective, or RPO, is the maximum acceptable amount of data loss measured in time. If a financial company has an RPO of 15 minutes, it means they absolutely cannot afford to lose more than 15 minutes worth of transactions during a crash. To achieve a strict RPO, you must architect solutions that back up data continuously rather than just once a day. There are several common disaster recovery patterns you must memorize for the exam. The cold pattern involves storing cheap backups in cloud storage and manually launching new servers only after a disaster strikes. This is the cheapest option but results in the longest downtime, making it suitable only for non-critical internal applications with very high recovery time objectives. The warm standby pattern offers a balanced approach by keeping a minimal version of your application running at all times in a backup region. The database is constantly synchronized, but the compute servers are kept small to save money. If a disaster occurs, you simply scale up those small servers to handle full production traffic, resulting in a much faster recovery time than the cold pattern. The hot standby pattern provides the fastest possible disaster recovery but costs the most money. In this architecture, you run a complete and fully scaled duplicate of your entire application in a second region. A global load balancer splits traffic between both regions constantly, meaning if one region dies, the users never even notice a disruption because the other region is already handling traffic. Managing state in your applications is a critical design challenge for reliability. You should always aim to design stateless compute tiers, meaning your web servers do not store any local session data like shopping cart contents. Instead, you should store that session data in a fast external database like memory store, allowing any web server to instantly replace a crashed server without losing the customer data. Decoupling your architecture is another vital strategy for building reliable systems. Instead of having 2 microservices communicate directly, you can use CloudPub, sub to place a message queue between them. If the receiving service crashes, CloudPub, sub simply holds onto the messages safely until the service comes back online, preventing a minor failure from causing a cascading system collapse. Testing your disaster recovery plan is just as important as building it. You should regularly perform automated disaster recovery drills to ensure your team actually knows how to execute the plan during a stressful outage. On the exam, always look for answers that promote automated testing and infrastructure as code, as manual recovery steps are prone to catastrophic human errors. Congratulations on completing this essential section on designing for reliability and high availability. To truly master these disaster recovery patterns and test your readiness, please complete the practice test attached directly to this lesson. Answering practice questions greatly improves your retention and ensures you are fully prepared for the certification exam. Remember that the practice test is included right here with this lesson, so take advantage of it to reinforce your active learning. Finish those questions, stay positive, and I will see you in the final section where we tackle cloud migration and modernization strategies. Welcome to the final section of our course, where we explore cloud migration and modernization strategies. In this lesson, you will learn how to seamlessly move existing workloads into Google Cloud and modernize legacy applications for maximum efficiency. This topic is incredibly important because enterprise clients rarely start from scratch, and they rely on you to transition their massive, complex environments safely. Get ready to discover the proven frameworks and migration paths that will elevate you to a master cloud architect and fully prepare you for the exam. Every successful migration begins with a thorough assessment of the existing on-premises environment. You cannot migrate what you do not understand, so discovering all running servers, software dependencies, and network topologies is your mandatory first step. On the exam, you will often use a Google tool called StratoZone to automate this discovery process and generate highly accurate cost reports before any actual migration begins. Once the assessment is complete, you must carefully plan the migration phases to minimize business disruption. It is generally a terrible idea to move an entire enterprise architecture over a single weekend, which is a risky strategy often called a Big Bang migration. Instead, the certification exam expects you to recommend a phased approach, migrating low-risk applications first to build team confidence before tackling mission-critical databases. The fastest and simplest migration strategy is known as lift and shift, which is also called rehosting. In this approach, you take an application running on an on-premises virtual machine and move it directly to a Google Cloud virtual machine without changing its underlying code. While lift and shift is incredibly fast, it does not take full advantage of cloud-native features like autoscaling, making it a stepping stone rather than a final destination. To execute a massive lift and shift strategy efficiently, Google offers a dedicated tool called Migrate to Virtual Machines. This service allows you to easily move hundreds of virtual machines from on-premises data centers or other public clouds directly into Compute Engine. It works by cloning your existing disks and orchestrating the entire cutover process, which drastically reduces the manual labor required for a large enterprise migration. Replatforming, which is often described as lift and optimize, involves making small but powerful adjustments to your application during the migration process. For example, instead of migrating an old on-premises database to a standard virtual machine, you might replatform it by moving the data directly into a fully managed service like Cloud SQL. This strategy immediately reduces the operational burden of database administration while keeping the core application logic completely unchanged. Refactoring, or re-architecting, requires you to rewrite significant portions of your application code to make it truly cloud-native. This often means breaking down a massive, old monolithic application into modern, independent microservices that run inside containers. While refactoring is the most expensive and time-consuming migration strategy, it provides the highest long-term return on investment by maximizing scalability and drastically reducing cloud compute costs. When a business decides to modernize its legacy applications, containerization is almost always the preferred architectural choice. Packaging an application into a container ensures it runs consistently regardless of the underlying infrastructure, eliminating the classic problem of code working on a developer laptop but failing in production. The exam frequently asks how to modernize applications, and moving them into Google Kubernetes Engine is typically the most scalable answer. To help companies modernize quickly without completely rewriting their software, Google provides a tool called Migrate to Containers. This powerful service takes an existing traditional virtual machine and automatically converts it into a modern, deployable container image. If an exam scenario asks for the fastest way to move legacy applications into Kubernetes without hiring an army of expensive software developers, Migrate to Containers is the correct solution. Moving massive amounts of data into the cloud presents a unique logistical challenge governed by the limitations of internet bandwidth. If a company needs to move petabytes of archived data, uploading it over a standard internet connection could literally take years. For these massive offline migrations, you should recommend the Transfer Appliance, which is a physical, high-capacity server Google ships to your data center so you can securely load your data and ship it back. For online data migrations where you have a fast internet connection, the storage transfer service is the ideal architectural choice. This fully managed service allows you to quickly and securely move large datasets from Amazon Web Services, Microsoft Azure, or on-premises storage directly into Google Cloud Storage. The exam heavily features this service because it automatically handles failed transfers, retries, and data validation without requiring any manual scripting. Migrating active production databases is incredibly risky because you absolutely cannot afford to lose customer transactions during the switch. The database migration service provides a highly automated and secure way to migrate relational databases into Cloud SQL with virtually zero downtime. It continuously replicates data from your source database to the cloud, allowing you to seamlessly cut over your application traffic whenever you are completely ready. Many large organizations cannot move everything to the cloud instantly due to strict compliance laws or heavily entrenched legacy systems. This reality creates a hybrid cloud architecture, where a company operates workloads in both the private on-premises data center and Google Cloud simultaneously. The exam will test your ability to design secure network connections, like dedicated interconnect, to ensure these two distinct environments can communicate seamlessly and privately. A multi-cloud architecture expands on the hybrid concept by utilizing multiple public cloud providers at the exact same time. Companies choose multi-cloud to avoid vendor lock-in and to leverage the unique strengths of different cloud providers, like using Google Cloud for data analytics while keeping web servers on another platform. Managing this complexity is a major theme for advanced cloud architect scenarios you will encounter on the exam. To manage the extreme complexity of hybrid and multi-cloud environments, Google provides a platform called GKE Enterprise, which evolved from Google Anthos. This platform allows you to manage Kubernetes clusters seamlessly, regardless of whether they are running on Google Cloud, an on-premises data center, or even a competitor platform. If a highly complex exam question asks for a single dashboard to manage security and deployments across multiple cloud providers, GKE Enterprise is the ultimate solution. When migrating a massive monolithic application to modern microservices, you should employ the Strangler Fig architectural pattern. This strategy involves gradually replacing specific pieces of the legacy application with new cloud-native microservices one piece at a time. Over time, the new microservices handle more and more of the workload until the old legacy system is completely strangled and can be safely turned off without any major service disruptions. A migration is not truly finished just because the servers are running successfully in Google Cloud. Post-migration optimization is a critical final phase where you actively monitor the new environment and continuously adjust resource allocations to save money. You must always remind your clients that the initial cloud architecture is just a starting point, and they should regularly review cloud monitoring dashboards to implement right-sizing recommendations. Cloud modernization is not just about changing technology, it is heavily about changing the organizational culture of a business. Moving to the cloud requires engineering teams to embrace continuous learning, automated deployments, and agile methodologies rather than relying on slow, manual approvals. The exam expects a professional cloud architect to act as a leader who champions this cultural shift and helps organizations gracefully overcome their natural resistance to change. As you wrap up your exam preparation, carefully review the official Google Cloud certification blueprint one last time. Ensure you can confidently design reliable architectures, secure identity management, optimize operational costs, and plan complex migrations. The exam scenarios are purposefully designed to be ambiguous, so you must always trace your answers back to the specific business requirements outlined in the question. Congratulations on completing this final section on cloud migration and modernization strategies. To solidify your mastery of these concepts, please complete the practice test attached directly to this lesson. Taking practice questions is the absolute best way to improve your retention and achieve total exam readiness. The practice test is completely included with this lesson, so rely on it for active learning. Take a deep breath, trust your hard work, and step forward confidently to conquer your certification exam.